Okay, this next video is a continuation of the linear models, and we're going to talk about uniform motion problems. These can be solved in a similar fashion, so let's take a look at uniform motion. This is basically your old distance, rate, time problem. You might remember from a previous course that distance is equal to rate times time. And then, of course, if you wanted to, you could solve for rate as distance over time, or you could solve for time as distance over rate, depending on what you needed. So that's what we're going to deal with here. So let's take a look at a problem here. A marketing executive traveled 810 miles on a corporate jet. So basically, that's one component. And then it says in the same amount of time, and that's important as well, that it took to travel 162 miles by helicopter. So it's going to give us, it also gives us some information about the rate of the jet and the helicopter. The jet is 360 miles per hour faster than the rate of the helicopter. And then it says find the rate of the jet. So what I like to do is I like to set up problem where you have your distance, your rate, and your time. And so the distance, the rate, and the time. Let's see here. And of course, time is distance over rate. So now we're given that the helicopter traveled 162 miles. And we're given that the jet traveled 810 miles. And they did this in the same time. So if we had a way to relate the two rates, we could write their times as distance over rate. We do have a way to do that because we know that the jet, its rate up here is 360 miles per hour faster than the rate of the helicopter. So we could let the rate of the helicopter be x, and then of course the rate of the jet would be x plus 360. Now you could do it the other way. You could let x be the rate of the jet, but then you'd have to let x minus 360 be the rate of the helicopter. So now if we know the distance and the rate, then the time for the helicopter's trip has to be distance over rate, which would be the distance of 162 miles over his rate, which is x miles per hour, of course. And then the jet traveled 810 miles, and his rate was x plus 360 miles per hour. So the idea is if we can solve for x, we can find the rate of the helicopter, and then once we know the rate of the helicopter, we can find the rate of the jet. So the key here is right here, same amount of time. So since this is the time for the helicopter's trip and this is the time for the jet's trip, we know that these two have to be the same. So here's your helicopter's time, here's your jet's time, and notice that I just set them equal. Now remember, this is a proportion. So on a proportion, I can just multiply them together. So I just took 810 times x and put that here. And then 162 times x plus 360, and I put that here. And then I distributed. I had to grab my calculator because obviously I couldn't do this in my head. You might think I could, but I couldn't. So I did 162 times 360 and got 58,320. And then if you subtract the 162x from 810x, you get 648x. And then of course it cancels there, right? And so you get 648x equals 58,320. And then when I divided 648 into 58,320, I actually got x equal 90 miles per hour. But that wasn't what it asked. It asked for the rate of the jet. So I had to get the rate of the jet, I had to add 360 to that. So I add 360 to that. Oh, darn it. That's not what I did, is it? I took 90, right? and then I added 360 to that. I knew what I was doing, I just wrote it wrong. So 90 plus 360 is the rate of the jet, and that's your answer. Okay, here's another one. A cabin cruiser, I'm guessing that's a boat, right? Left a harbor and traveled to a small island at an average speed of 24 miles per hour. On the return trip, the cabin cruiser, or the boat, returned at an average speed of 16 miles per hour. And then it gave us the total time for the trip was 5 hours. And so they want to know how far this island is from the harbor. Well, here's something to think about. You got two trips, to the island and from the island. And so the distance to the island and the distance from the island we're going to assume are the same. We're going to assume they took the same route. And you know the rate to the island was 24 miles per hour. You knew the rate from the island was 16 miles per hour. And notice that time is distance over rate. So the time going to the island would have to be x over 24, and the time coming back would have to be x divided by 16. Now here's the good part. The total time for the trip to and from was 5 hours. So that means that all we have to do to solve this is add these two times together and set them equal to 5 hours. Now this is a rational equation, and the denominators are 24 and 16. So I need a number that 24 and 16 will nicely divide into, and 48 comes to mind. So let's multiply this first term by 48. And so when I multiply x over 24 by 48, since 24 goes into 48 two times, I'll get 2x. And here 48 times x over 16, 16 goes into 48 three times, so I'll get 3x. Now don't forget, you also have to multiply this number 5 by 48, and that gave me 240. And now when I add 2x and 3x together, I get 5x equals 240. And now all you have to do to solve for x is divide by 5. So the distance, the distance to the island was 48 miles. And that was the answer to the question. Now, let's run through some other problems you might run into. Let's talk about work problems. These are usually when two entities are working together on something. When two things work together, they can get it done quicker, but the time is not what you might think it would be. Okay, so let's talk about two water pipes are working together to fill a tank. You have a large pipe, can do the tank alone in 9 hours. You have a small pipe, can fill the tank alone in 6 hours. Now what that tells me is that the large pipe does 1/9 of the job per hour. So if the large pipe would work X hours and it does 1/9 of the job per hour, then it would actually do a total of X times a ninth. That's what portion of the job or what portion of the work that pipe's going to do. So I'm going to let X be the amount of time the large pipe works, and also the amount of time the small pipe works, because we're going to assume the job is complete once the tank is full. And so since the pipes are going to start at the same time, they're going to finish at the same time. So as I said, the large pipe, the rate of work, it does 1/9 of the job per hour. The small pipe does 1/6 of the job per hour. So the total portion of work done by the large pipe would be X times a ninth, or X over 9. The total work done by the small pipe would be X times a sixth, or X over 6. And now here's where it might be a little confusing. This is the portion done by the large pipe. This is the portion done by the small pipe. Now, when I say portion, I mean like did 1/3 of the job, or 1/10 of the job, or 2/3 of the job, or whatever. And then this guy did the rest of the job. So if this did 1/3 of the job, then this had to do 2/3 of the job. Or if this did 1/2 of the job, this had to do half of the job. Or if this did 3/4 of the job, this guy has to do 1/4 of the job. So what I'm trying to point out to you is that when you add these two portions together, they should equal one complete job or one whole job. So if we add those two portions together, they must equal 1. And so your equation is x over 9 plus x over 6 equals 1. And then if you multiply both sides by 18, or actually all three terms by 18, the lowest common denominator, this becomes 2x, this becomes 3x, and 18 times 1 is 18. And then you add these together, get 5x equals 18, and divide by 5, and you get x is 3.6 hours. Now, there's another question here that says, what if we open an outlet pipe that would empty the tank? So this would be working against the other two. So we would use a minus there. So it would work like this. We still got this pipe doing this portion, this pipe doing this portion, but this pipe is working against it, so we would do minus, and its rate is 1/4. And so we would solve that the same way, except our common denominator would be different. It would be 36. So if I multiply everybody by 36, this would give me 4x plus 6x minus 9x, equals 36. So I get x equals 36, which makes sense because with that other pipe working against him, it would take a lot longer for the tank to empty. I'm going to let you can just freeze the video on number 9 here and take a look at it. But basically it's very much like number 8, but you've got 3 entities working together here, and their rates are 1/20th, 1/30th, and 1/60th. But read through that one and see if you can follow what I did. It's very much like I did the one before it, but you get your final answer there is 10 minutes. Okay, I've got a couple more here that I want to get through before my time runs out on this. Okay, so here it says find 3 consecutive odd integers such that twice the sum of the first and third integers is 21 more than the second. Well, consecutive odd integers differ by 2. So one integer would be x, one would be x plus 2, one would be x plus 4, like, 1, 3, and 5. 1 plus 2 is 3, 1 plus 4 would be 5. So it says twice the sum of the first and third. So if I add the first integer to the third integer and then double it, I get 2 times 2x plus 4, and that has to equal the 21 more than the second integer. So it would be the second integer plus 21, and that equals x plus 23. And then all you have to do is multiply this out, get 4x plus 8 equals x plus 23, and then subtract x, and you get 3x equals 15. So therefore, divide by 3, x is 5, x plus 2 would have to be 7, and x plus 4 would have to be 9. Okay, on this last one, I'll let you read it, but basically you're given that a rectangle has a width, and then the length is 4 more than 3 times the width. So this would be the length, 3w plus 4. So let w be the width, 3w plus 4 would be the length. Now, we're given that the perimeter is 48 inches. So if the perimeter is 48 inches, remember perimeter would be twice the width plus twice the length. And we're given that equals 48. Well, all we have to do is replace L with 3w plus 4, and now we can solve this equation for w. So if I distribute the 2, I get 6w plus 8 there, and then 2w plus 6w is 8w, and then over here I get 48, right? So notice I subtracted 8 from 48, and that's how I got the 40, because there's an 8 over here, and I had to get rid of it. So I got 40. So I got 8w is 40, and then divide by 8, I get w equals 5, and then just plug 5 into this expression here for w, and you get 3 times 5 is 15, plus 4 is 19. So the dimensions are 5 by 19. The width is 5, and the length is 19 units. I guess the units would be inches, so 5 inches by 19 inches here. And that pretty much ends this video series on linear models.